Okay, we are in CE 363, and in this specific session, we will continue calculating the lateral earth pressure under special circumstances, and I will keep them as notes for your reference. The first note is, as shown over here, if I have a uniformly distributed surcharge pressure. If a uniformly distributed surcharge pressure Q distributed surcharge pressure Q per unit area acts over the ground surface. If something like this happens, then what we will be doing is that we are going to modify the lateral earth pressure equation. I would say, sigma H prime is equal to sigma V prime Ka minus 2C prime squared of Ka, right? Now, the only modification over here is that while calculating sigma V prime, what I will be doing, instead of gamma prime times H or gamma prime times Z plus Q. So while calculating sigma V prime, I will add this Q as an additional component. This was for the active earth pressure, and for the passive one, I'll be using the same equation, sigma V prime Kp plus 2C prime squared of Kp. And again, I'll be calculating the sigma V prime based on this gamma prime times H plus Q. Okay, so that is the logic behind this. Now, this is the first note. And the second note is that, for example, if there is a groundwater table, and the soil below the water table is fully drained, and the soil below the water table is in fully drained condition, then of course lateral earth pressure must be expressed in terms of the effective weight of the soil. In terms of the effective weight of the soil. Okay, so we are going to be using gamma prime, which is gamma saturated minus gamma water. Okay, and while calculating the effective shear strength parameters, while calculating the lateral earth pressure, effective shear strength parameters needs to be used. Which are C prime and phi prime must be used. Okay, which means that, as we already mentioned, I have sigma V prime times Ka minus 2c prime squared of Ka, right? So for this one, I'm going to be using gamma prime times h. And for this one, for the Ka, I can use 1 minus sine phi prime plus 1 plus sine phi prime. Okay? So that is the idea. Now, let me actually take this a bit downwards. This is another situation that we need to handle. One thing that is very important while calculating the effective, while using the effective parameters, you need to be noting that the total thrust active thrust, you can calculate this as P total. I'll be having PA, and we are going to be using effective parameters plus the hydrostatic pressure. Please note that while calculating PA, I'll be using sigma H prime, and this is the hydrostatic water pressure. Okay. Of course, we'll be solving example problems on this. And one thing, when we calculate sigma H prime, we will be using gamma prime, C prime, and phi prime. Okay, please note that that is the case. And the hydrostatic water pressure behind the retaining wall is important to be used in the calculations. All right. Now, we might have situations where we need to calculate the total thrust based on undrained conditions. Let's say, okay, for the undrained conditions, this is especially valid if you want to calculate the forces under earthquake loading. For the undrained conditions, I would like to remind you that UU test result over here okay. If you remember, for the undrained conditions, I have the parameters as Cu and phi u is equal to 0. If you remember the sigma versus tau graph from the UU test. Now, in that case, I have Ka is equal to 1 minus sine phi prime plus over 1 plus sine phi prime. Since phi prime is 0, then I'm going to have 1. Similarly, Kp is equal to 1. Okay, and the lateral earth pressure sigma V prime is equal to, sigma H prime is equal to sigma V prime times Ka minus 2 C prime squared of Ka, right? Since Ka is equal to 1, what we can do in this case, simply sigma V prime minus 2 times Cu for the undrained condition. All right, so that is the third note. And the fourth note is that, let me actually take this a bit downwards. In the case of multi-layered soils, let's say that is the fourth note. If we have different soil layers, then let's consider this scenario. I have soil 1 and soil 2 with different parameters. Okay. Let me take it over here. Let's imagine a scenario where we need to calculate the active pressure. For soil 1, let's assume the active pressure let's say, okay, let's imagine I have, a tension zone, and let's assume that this is PA1, okay, and for PA1, what I can do, or let's say sigma H prime 1, sigma H prime 1 is equal to sigma V prime times KA1 minus 2 times C1 prime square root of KA1. Okay, and this is for the bottom of soil 1, but for the top of soil 2, what I will be doing is that I have sigma H2 prime, I'm going to have sigma V prime times KA2 minus 2 times C2 square root of KA2. So you might have jumps over here, for example. Let's say this is PA2 and that will be sigma H2 prime. Again, we will be solving examples on this, but the idea is that we are going to have different KAs at the boundaries. So let me actually write it down. For example, this is a boundary. Okay. In this boundary, different KAs at the boundaries. Okay, so please note that you should be using different KAs, especially at the boundaries. That is important. And one thing before we actually solve an example problem is that the Rankine's lateral earth pressure for sloping ground surface. Okay, let me actually take this over here. This is an easier way to discuss. Now, if you remember our previous assumptions, Rankine's lateral earth pressure theory is valid for both level surfaces and sloping ground surfaces. If we have a sloping ground surface as shown in this figure, we are going to be calculating the lateral earth pressure which are acting in a direction parallel to the ground surface. Let me actually note this for you as well. I have Rankine's theory assumes active and passive lateral earth pressure assumes that, okay, this is not the best writing. Okay, let me actually take this over here. Assumes that active and passive lateral earth pressures act a direction which is parallel to the ground surface. Okay, this is crucial. Here, as shown in this figure, the ground surface inclination angle is beta, and please note that phi is the angle of internal friction. If we have such cases, the pressures will act parallel to the ground surface. In other words, these arrows are parallel to the ground surface. Okay, so please keep this in mind. So there is one more difference over here. In order for you to calculate Ka, you should be using this formula, which includes both the ground surface inclination angle plus the angle of internal friction for the soil. And again, Ka is equal to 1 over Kp. This doesn't change. One quick note, if you want to calculate the active thrust will include a component cosine B. Please note that this is going to be included when calculating the active thrust for the lateral earth pressure calculations. Okay, thank you. I appreciate your time.